Let f be a function whose second derivative is given below. The points at which the first derivative equals 0 are x equals -2 and x equals 0. Use the second derivative test to determine if these points give a relative minimum, relative maximum, or if the test fails. I like these exercises because this really gets to the heart at what this second derivative test is asking you to check. We can use the second derivative to tell whether or not a critical value is a relative maximum or a relative minimum. If you evaluate the second derivative at a critical value and you get a number that's bigger than 0, first of all, that tells you that at that point the graph is concave up. And what that means, since it's concave up, is there will be a relative minimum at x equals c. Similarly, if you find a second derivative or evaluate the second derivative at a critical value and you get something that's less than 0, that will tell you that it is a relative maximum at x equals c. And that is because at that point the graph is concave down. And lastly, if f double prime of a critical value is 0, then all we can say in this situation is that the test fails. There is not a first derivative to go back to in order to use the first derivative test. If we had the original function given to us and we found the first derivative and the critical values and we found that the second derivative test fails, we would have the first derivative to go back to use the first derivative test. But in this situation, we can only say that the test fails. So that being said, we know up here in the original problem we have two critical values, x equals -2 and x equals 0. So what we need to do is we need to come over here to the second derivative and evaluate it at -2. So when you do that and you substitute the -2 in for x and you add 1 to that and cube it, that tells you that the 21st is positive, and then the -2 plus 1 will give you a negative cubed. And anytime you cube a negative number, that will give you something that is negative. So this entire answer is negative, which means that f double prime of 2 is less than 0. So looking over here at the second derivative test, conclusion, if the second derivative at the critical value is less than 0, then you have a relative max. All we can say about this is that there is a relative maximum at x equals -2. So there's one answer. And if you use this similar technique, this sign analysis technique, for when x equals 0 and you find that f double prime of 0 is greater than 0, then that tells you there's a relative minimum at x equals 0. And I want you to be really sure about where these numbers over here are coming from, because I wasn't. Apparently I forgot the negative here. So that this x equals -2 comes from what we put into the function. This x equals 0 comes from what we put into the function. So there's a relative max at x equals -2 and a relative min at x equals 0.